Welcome all back to some Algebra 3 business. Today we're talking about linear functions, slopes, and their applications. So first off, let's talk about linear function. Now we'll step back even more. It's about functions in general. Now functions can come in multiple ways. Our linear functions, our quadratic functions, and then multiple other kind of functions. Of course, little arrows at the end. Sometimes they stop, sometimes they don't. Now we know these are all functions because of a vertical line test. We do a vertical line here, it touches once. Vertical line touches one, vertical line touches one. So those are the worst vertical lines ever, but that's okay. Let's kind of move on with that. Now, again, linear functions can come in the form of f of x equals mx plus b. They can also come in the form of ax plus by equals c. This is what we call standard. This is what we call slope intercept, which we'll talk a bit more. Intercept. Now, these are all examples of linear functions. For example, now they're positive and negative. Let's talk about the positive ones. Positive ones are anything that goes uphill from left to right. So this blue one is a positive slope. This green one's a positive slope. This red one is a negative slope going down, and this pink one is also a negative slope. Now the equation f of x equals x is what we call the identity function, also known as the parent function. It's the original one per se. A normal f of x equals x is same for every value of x, y will equal the same. So when x is 3, y is also 3. Okay, so for every value we put in for x, y will have the same value. Now, let's talk about the slope intercept form as we were mentioning earlier. So f of x equals mx plus b, but let's talk about these actual parts of it then. Now, x is any point on the graph, on the equation. F of x is the value of y. Now, sometimes things can change that. So for example, the point B is what we call the y-intercept, where we start on the y-axis right here. M is our slope, of course. It's the rise, so the change vertically, over the run, the change horizontally. Now, for example, here it's telling us to write the equation in slope-intercept form of a line that has a slope of 3 and a y-intercept of -2. So again, f of x always stays as f of x. So f of x equals our slope, 3x, it's plus b, but because it's a -2, put -2. Now, if we're going to graph this, we start at our y-intercept at the -2 right here. There we go. And then from there, we do a slope of 3. Now, this is 3 over 1. All whole numbers have a value of 1 in the denominator. So we go up 3 spots, our rise, 1, 2, 3, and then positive 1 on our run. 2, 3, 1, 2, 3, 1, 2, 3. You can also go backwards, -3, 1, 2, 3, as long as you do -1, because -3 over -1 has the same value as +3 over 1. So, and then we just play a little game of connect the dots from here up to there. That's it. Now let's look at slope. Now, a little bit closer to slope. Slope, again, is the ratio of the vertical change over the horizontal change. Now, in the real world, those kind of problems are, we call them rate of change. So if you ever see the term, hey, find the rate of change, they're telling you to find the slope of that problem they're doing right now. Whether it's acceleration, velocity, or just an actual rate of change over time. Now, slope, or m, is equal to y2 minus y1 over x2 minus x1. Now, like we've talked before, this little 2, this little 1 have no actual value. They're just used to tell the difference between one set of xy coordinates and the second set of xy coordinates. So for example, here's our first set, x1, y1. This is our second set, x2, y2. This formula goes as it is then. We start at y2, -14, minus the value of y2, or y1, sorry, which is -7, over the value of x2, 7, minus the value of x1, 5. We simplify this, we end up getting -7 over 2. Let's do that one more time. kind of practice that one more time. So pause this for a second, then you do this yourself. Bloop, 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 bloop. All right. So hopefully you get the right answer, but let's kind of compare answers. So if I'm doing this again, I start with my y2, this -1, minus my y1, which is -3, over x2, which is my -2, minus my x1, -7. Again, these switch each other to positives. Give me a value of 2 on top and a 5 on the bottom. So this is the slope that I hope you got as well. But what about lines, horizontal lines and vertical lines? What kind of slope would they have? Well, that's a good question. This kind of checks us out. So they gave us a set of coordinates, an x1, y1, and an x2, y2. All right. So let's check this out. So if we're going to set up our equations, we will set up y2, which is 4, minus y1, which is 4, over x2, 5, minus x1, -3. On the numerator, we get a 0. In the denominator, we get 8. So 0 divided by 8 will always give us a value of 0. 0 divided by anything will always give us 0. So this is known as zero slope. Zero slope. Or, of course, the letter 0 slope. Now, but is this line a function, yes or no? Well, vertical line test says yes, only touches a 1. So it is also a function, though. So just because it has no slope doesn't mean it is not a function. But what about vertical line? Is that a function? Before we even do the slope of that, is that a function? Well, vertical line, we draw it straight down, says it's not. So that's not a function. And my ink's running out, I think. Function. But let's go and find the slope. What kind of slope does that vertical line have? Well, let's check that out. Here's my x1, y1, x2, y2. Let's try those out. So we'll say y2, -4, minus y1, 0, over x2 minus x1. Numerator, we get -4. Denominator, we get 0. And if you've ever been in a math class in the last so many years, you hopefully been told by your math teacher that you cannot divide by that. Cannot divide by 0. You can never divide by 0. The world will implode if that happens, if you're able to do that. So when we have a value of 0 in the denominator, that's what we call no slope, or the more mathematical term, undefined. Undefined. Okay, same, they're one and another. No slope means it can't exist. 0 slope means it exists, it just has a value of 0. Now, let's check out some of this application stuff right here. So as far as the application of slope, when you're talking about the grade of a hill, that's where you see it out in the real world. You're talking about the rise of the road over a given, and also the lower rise going up or down over a certain vertical change. So for example, if a road has a 4% grade, that's saying that for every 4 feet this is going up, it can only go up 4 feet for every 100 feet traveled. So so our example here, a construction law regarding access ramps for the disabled states that every vertical rise of 1 foot, so every change vertically, has a horizontal change of 12. So let's kind of go back up here. So here, to get a 4%, this took the vertical change 4 over the horizontal change 100. You would divide that, you get 0.04. And in percentage forms, you move your decimal over twice, bam, bam, you're getting 4%. So same thing here. Let's divide that. If you divide this, you get roughly 0.08333 repeating. So if we're moving this over twice, we can either round it to the nearest whole percent, which will be it'll be 8% grade, 8% grade. But if you want to be more exact, you can call it 8 1/3% grade. Okay. And our last little way we can apply this is in possibly any money. We all like money. Let's talk about money here. So a cellular company charges you $60 for a phone. So it's supposed to be for, not or, for a phone. And $29 per month. So under this certain plan they have. Now we have to write the equation first. So when writing the equation, we're looking for slope and y-intercept. Or in real world terms, we call that rate of change, rate of change, and our initial cost. What it costs us before we even go anything past here. What do we have to pay now so we can have this? So our rate of change, as it says, is $29 per month. $29 per month. And our initial cost at the very beginning is $60. So if we're going to write an equation to determine the cost, C of T, to operate our phone with this company for so many months, T amount of months, well, C of T, so the cost at T amount of months, is equal to our rate of change, our slope, $29 for T months, plus the initial cost, $60. So then they ask us, hey, well, what would be your total cost for 6 months? Well, let's check that out. So we do C of 6 months, that's equal to $29 times 6 months plus the $60 initial cost. We multiply that, we get 174 plus $60. So our cost for 6 months is equal to 174 plus 60, which gives us a total of $234. 0 cents. All right, y'all. That's all I have for you today. See you next time. Bye.